Hello and welcome to my channel. I call this video Thermostat Wars, My Struggles, because it was a struggle. I recently had to put in some new thermostats for a new boiler and heating system I had installed. And I started out real simple and then it just got very complicated. So this is an attempt to simplify my choosing or my choice of several different thermostats and what I had to go through to get them to work, and some of the features of some of them as well. So let's get started and take a look. Okay, let's talk about thermostats. I'm going to go through several different types of thermostats and show you what I found out and how to hook them up as easily as possible. Okay, this is my new heating system. It replaces one that was about 25 years old, and it was becoming very expensive to maintain. So I had installed a Viessmann boiler, which is a propane-fired hot water boiler, and it is a modulating boiler, which means it can adjust its output from anywhere from 80,000 to 120,000 BTUs. The zones are shown over here in the right picture, and all this shows is I have 3 hot water zones for radiators, and that's right here. And then I have 2 zones that are fed by this line for radiant underfloor heating. And there's a mixing valve here which mixes the hot water with cold water to get the right temperature. So I wrote down some thermostat requirements I thought I would like to have. First of all, I wanted it to be programmable, so a 7-day program where I can adjust the program to turn the heat up and down depending on what my requirements are. I wanted it to be Wi-Fi connected because when we go on vacation for a weekend or come back from vacation, I want to be able to control the heat in the house or the air conditioning in the house. It's got to be user friendly. I don't like the idea of frequently changing batteries. So the batteries have got to last a long time if it has batteries. It should retain the settings in a power failure situation, so I don't have to reprogram it. And it should ideally have a heat mode and a cool mode, 1-stage heat and 1-stage cool. Should be reasonably priced, and it should have C-wire capability, and we'll talk about that in a moment. Okay, these are the thermostats I wanted to consider. The first one here is a dumb thermostat, and I have a bunch of these around the house. And they're basically programmable, and they use batteries, but that's about it. None of the other characteristics. I do have one Nest thermostat in the bedroom, and that's a 4th generation learning Nest thermostat. They also have a basic one, which is a lot less money, but doesn't learn and has some limited capabilities. And as I said, I'm already using this one, and it's pretty user-friendly. This is a Techmar one that was recommended by my heating contractor. And this is the particular model he recommended for me. Also, this is a Honeywell 9000 that I tested out, and I really liked, and I got this off of Amazon. Okay, so next I did an evaluation. Initially, my heating contractor said, just go with dumb thermostats, they're fine. Dry contacts, they're simple, they always work, there's no problem with them. But I bounced them up against my criteria or requirements, and the dumb thermostat was programmable, had no Wi-Fi connection. It was pretty user-friendly. You did have to change the batteries probably every 6 months. It did retain settings in a power failure, but it was okay. But again, I didn't like the idea of having batteries. It did not have 1-stage heat and 1-stage cool. It was just heat. That was it. It did have a reasonable price, but the C-wire, there was no C-wire in there because it used batteries. So you can see the things in red here were the things where it fell down. Next, I went to the Nest thermostat because I would have liked to have kept Nest thermostats just for consistency throughout the house. And I did like the learning Nest thermostat. Um, and so I actually then bought some basic basic Nest thermostats, and I'll mention about that in a minute. The Nest thermostats were programmable. They had Wi-Fi connection, user-friendly, no frequently changing batteries. It was supposed to be, it's supposed to charge itself. The batteries are supposed to charge itself from the heating system. It did retain settings in a power failure. It had one stage heat and one stage cool. So this one I was using in the bedroom was actually able to control both the heat in the winter and the air conditioning in the summer. It was reasonably priced, but only the basic one was reasonably priced. And you have to look at your local utility to see what kind of rebate you get. In my local utility here in New England, I have Eversource, and they give you a $100 rebate up to three thermostats. So the reasonably priced one was, I think it actually ended up being free. The basic one was $100, and I got $100 back. So that was, that wasn't too bad. Free was pretty good. The C wire, it had a C wire, but it also had a battery in it. I'm going to mention more detail about that. The programmable Tecmar, it was programmable, Wi-Fi connected, user-friendly, didn't have any batteries. It retained settings in a power failure. It was a 2-stage and 1-stage cool, but it wasn't really reasonably priced. The one he recommended was this one here, which is $266. So, almost $300 for a thermostat was kind of high. Even with my rebate, I would have had to pay like $170 for it. Programmable is the Honeywell, very programmable. Wi-Fi connected, user-friendly, basically checked all the boxes. Reasonably priced. I got it, it was $140. With the rebate, I got it for $40. It had a C wire and it didn't have any battery in it. I like this one because it had a large screen. Unlike the Tecmar, it had a relatively small screen and only had 2 or 3 things on the screen, parameters that you could see. The Honeywell had a bunch of stuff on there. It had the outside temperature, outside humidity, inside temperature and humidity. Had the set point right there. You didn't have to go up and touch anything if you wanted to see what was going on, unlike the Nest. I wanted to really try the Honeywell one and see if I could get that to work. The other thing about Nest that kind of turned me off to this, if I got the same one I had before, the learning one, it was almost $280 as well, or $290. So even with the rebate, it was $190. The other thing about Nest that turned me off is I just recently got a notice that Nest, or Google, who bought Nest, has just announced that they're not going to support Generation 1 and Generation 2 of the Nest learning thermostats. Now, I have Generation 3, so I really wasn't affected by that. But the thing that's disturbing is Nest not only said they weren't going to support updates and they weren't going to support enhancements or bug fixes in the thermostat, but that once they stopped supporting it, you would no longer have the same functionality you had before. In other words, you wouldn't have Wi-Fi connected to it. So it's basically a dumb thermostat equivalent to this one here, the programmable dumb thermostat that I was just talking about. And to me, that seemed kind of draconian, that you pay $266 for this thing, and when they pull support for it, it basically goes back to being essentially a dumb thermostat. And since I had Generation 3, I figured I was next on the hit list. So that kind of turned me off to Nest right away. I wanted to show this diagram because even though it's Nest and I've kind of just counted them, it does show what the different wires going to a thermostat is. For example, RH means it's the power from the boiler or the heating system, and the sub H means it's heating. The RC is same thing, it's power from the cooling system or the air conditioning system. W is the wire that turns the heat on, and Y1 is the equivalent wire that turns the cooling on. And then G is the fan. So if you want to just have the fan running, you can, and not have the cooling or the heating on. You can just have the fan blower running if you have forced hot air. Okay, so again, just information about what all of these wires mean. The other ones we're going to talk about in a little while. Okay, let's talk about the famous or infamous C wire. C stands for common. The reason there should be an extra wire, a C wire, that is used in most thermostats is because the C wire provides more power to charge the internal battery when there's insufficient power from the heating system. Initially, when I had my Nest set up, it worked great for about 3 to 4 months, and then the battery wouldn't get charged. And I'll mention that in the next slide or two. So I had to hook up a C wire to keep the battery charged, so I didn't have to take it off and charge it with another connector or take it offline. Another reason for a C wire, there are a couple of thermostats. I mentioned the Honeywell one, which doesn't have a battery. It has capacitors in it. So you absolutely need a C wire there to keep the capacitors charged up. And it's always a good idea to have it, in my mind. So how do you get a C wire? Well, you run a dedicated wire to the thermostat from the heating system. You use a separate wire, hopefully that's already in your thermostat cable. Most thermostat cables are 3 and 4 wires, so there should be an extra one in there, hopefully. You also can use an unused or unneeded wire. Like I don't have forced hot air, so I don't use the G cable, the G wire, which is the fan wire to turn on the fan. The other thing you can do to get a C wire is buy and install a C wire power adapter. You need one for each zone. They're about $30 a piece. So if you get $3, that's 90. 3 zones, that's $90. And then the C wire power adapter has got to sit in the boiler, in the furnace, or your heating system. It sits down there in the basement where the heating system is. And as I said, you buy one for each zone, and you can use that C wire adapter. Okay, let's take a look at hooking up a thermostat without the C wire. This is for dumb thermostats or smart thermostats that have a battery. First, find the boiler terminals where the thermostat terminal strip is, and connect the red wire in the boiler terminal strip to the red or the RH terminal on the room thermostat. Connect the white wire in the boiler terminal strip to the white contact or terminal in the room thermostat. Now there'll be 24 volts AC that the boiler will be supplying between the red and the white terminal. This is the power that is coming from the boiler and going to the thermostat, which will hopefully be enough to charge the battery in the smart thermostat. One thing to remember is that the red and white wires are interchangeable for dumb thermostats, but only dumb thermostats. For a smart thermostat, you cannot reverse the wires, and the red terminal in the boiler terminal strip has got to be connected to the R or RH terminal in the room thermostat, and likewise with the white thermostat. After a few months of use, you should be able to find out if the battery is still alive and it's being charged. Okay, suppose you want to attach a C wire to your system. How do you do that? Well, it's pretty easy if your system has a C wire in it. You'll identify the C terminal in the boiler thermostat terminal strip, and usually it's right next to the thermostat terminals. You run a wire from there to the C terminal identified in the room thermostat. Keep the wire from the 24 volt AC going to the red wire of the thermostat, same as before, either the R or the RH terminal, and you connect the white wire from the boiler terminal strip to the white contact on the room thermostat, either identified as W or W1. Now you can check this pretty easily by measuring with a voltmeter between the C terminal and the red terminal, either in the thermostat or in the boiler. and it should be 24 to 30 volts AC. And you can measure that both at the terminal strip in the boiler and at the room thermostat. Now, the voltage between the C terminal and the white wire is 0 when the thermostat is off, but when the thermostat is activated and calling for heat, then the voltage should be 24 to 30 volts AC as well. Now, once again, the red and white wire are not interchangeable on a smart thermostat, which we're talking about here. Hopefully, when you set this up, you will be able to identify those wires very clearly. In my boiler also, there is a 1 amp fuse to protect the thermostat circuits. My installer didn't know if there was enough current for multiple thermostats. If there's a 1 amp fuse in the boiler to protect those circuits, that should be plenty of current for multiple thermostats, more than 3 or 4 probably. So that should work out fine. So again, test the voltages, and you'll be well on your way to getting this work. Now, I did this, and it still didn't work. And the reason it didn't work was because I had stripped the wires going in the thermostat about 1/4 of an inch, and it wasn't enough. I had pushed the wires in, but the bare part of the wire was not making contact. So the reason mine didn't work is because I had to strip it to about 1/2 an inch to 3/4 of an inch of wire, and then when I stripped it that much and shoved the wire into the terminals on the thermostat, everything worked fine, and it worked great. It all worked. So be aware of that. Okay, for those of you who want to know in a little more detail what's happening in a smart thermostat with a battery, here's what I think is going on. 24 volts AC coming from the boiler is rectified using a charging circuit similar to a diode, goes through the battery to charge it, and then returns on the white wire back to the boiler. Now, this keeps the battery charged, hopefully, for a long time, but in my case, after about 3 to 6 months, the battery died. I had to remove it, charge it up separately with a cable, and then put it back on for another 3 to 6 months. This battery is continuously charged with a trickle amount of current, whether this thermostat switch or relay is closed or not. So what happens with a C terminal? Well, with a C terminal, the battery has an alternate way to get charged, and that's through the common that returns back to the boiler and provides a lot more current. So it should keep the battery perpetually charged. And for those thermostats that don't have a battery, they have a bunch of supercapacitors in there. It'll keep those charged. So that's what's going on. Once again, I'd like to reiterate that the red and white wires are not interchangeable, and you got to be careful how you hook them up, and I'll show you that in the next slide. Okay, this picture here shows the wiring in my boiler. This cable here on the right, this cable right here is the cable that goes to the thermostats up in the rooms and connects to this terminal strip. This cable here is all the C terminals, and I'll show you a close-up of that and what I mean here. In my situation, the C terminals are in the middle of 3 terminals that go to the room. So for example, this is zone 1, that's the red wire to zone 1. This is the white wire to zone 1. And the middle terminal is the C wire to zone 1, the master bedroom. Okay? And here's what I was talking about before. This is the second zone, and this is a green wire that goes to zone 2, and this is the blue wire that goes to zone 2. So these are the contacts that go up to the thermostat. This is the C wire again that goes to the guest rooms. And again, this is the zone 3 and 3. This is brown and yellow, and the C wire is in the middle. So the red wire for zone 2 is really going to be green, and the white wire is really going to be blue. And that's what I was talking about. You got to keep it clear, and you can't reverse them. And this is the red wire. It happens to be brown, and this is the yellow wire, which is supposed to be white. So red and white is brown and yellow in this case, and you got to hook it up accordingly, and then it'll work. Okay, so this has 9 terminals, 3 for each thermostat. So what did I learn from all this? First of all, always turn off the power to the heating system when connecting wires. That's kind of obvious. The easiest approach, in my opinion, is to use the C wire in the heating system. Number 3, I tried an isolated power system via transformer because my heating contractor says, oh, you don't want to dig into the boiler and look at all those terminals and everything. It wasn't that bad, to be honest with you. And I could not get the isolated power via a transformer to work. The reason is the C wire is a single signal circuit ground, and it's different from the chassis ground. They're not the same. A safety green lead or chassis ground is the green wire that goes through your power cord. It's the third connector on when you plug in a plug. And they're not the same, they're separated, and there's a reason for that. The C-wire adapters require, as I said, one C-wire adapter per zone. They're about $30. They got to be located in the boiler. All C-wire commons are the same signal and circuit ground. In other words, you could really use just one C-wire and connect it up to every thermostat in the house, and you'd probably be okay. I made a separate one because they're all connected together, but I figured, if it needed more current, I would feed one C-wire separate to each thermostat. I only have three zones. The safety ground is green lead ground. That's the power line. The chassis ground, that's to keep people from getting electrocuted if something goes wrong, if there's a fault. Okay, so that's what I came out with. And once you take these lessons and these tips, it should work fine. It should work fine. Okay, that's my 2 cents for this video. If you had any experiences with thermostats, let me know. I have hooked up the Honeywell one that I showed you earlier. It works great after I got those things ironed out. It's very stable. It controls the temperature great. It's a nice, big, easy to watch screen. And I'm not worried about them stopping support on it. Honeywell's been around for 100 years, and they've made thermostats for a long time. And I'm really happy with that. And eventually, I think I'm going to, for $40 a piece after my rebate, I think I'm going to switch over the other ones too. So thanks for watching. Please like and subscribe, and I'll see you in the next video.